We are on week number 4. On Friday, you looked at the sleep survey task and you started to remember and review and relearn why we have all these different forms of rational numbers. How if you have a fraction, you can write it a different way. If you have a decimal, you can write it a different way. And a lot of times making comparisons requires that you put things in a different form. So, and this is something you started working with in 5th and 6th grade. We're going to become a little bit more mathematical about it today, and we are going to focus on how to turn every single fraction into a decimal. So right now you should all have page 11 in front of you. So get page 11 out, and here we go. Okay, first of all, on the top, we have a little fill in the blanks here. It says, did you know? And I already filled in the first word for you. If a number is written as a fraction in the form a over b, and you can see these 3 examples right here. We have a fraction, 7/8. We have a fraction, 9/20. You have a fraction, 5/9. If that number can be written as a fraction, it can always, I'm just going to underline that there, it can always also be written as either a repeating or terminating decimal. And we're going to make sure today we really thoroughly understand what that means for a decimal to repeat or terminate. And we're going to make sure we understand how to go from said fraction to the decimal. These numbers can also be written as a, what was the other form we looked at with the sleep survey task? Oh yeah, we can also write them as a percent. And we'll get back to that a little bit more tomorrow. Today we're going to focus on the mathematics that's happening to make this happen. There's some that you just have memorized, like we know that 1/2 is 0.5, and we just kind of remember that and we understand that based on different things. Some people look at it as 0.50 and looking at 50 cents, or like 1/4 is a quarter, 0.25, but why are those things equivalent? Why are they in fact the same thing? And there's something I want you to write over here to help you kind of understand why, okay? In the instructions, it says use long division to change each fraction into a decimal. Then use your calculator to check it. And I'm going to show you how to do all of that on these first 3 examples. And then I'm going to let you try the next 3 and see how you do, okay? So let's circle these words long division. Long division. Why in the world would long division be involved? Well, let's give ourselves a little note over here. So go ahead and circle that like I did long division. Draw an arrow over here. If I have a fraction in the form a over b, whatever integers a and b are, okay? If I have a fraction in the form a over b, one big thing I need to recognize is that fraction bar, and this is something I know you talked about in elementary, because every time I ask my 7th graders, what does the fraction bar mean? Do you know what you all say? Divide. The fraction bar means divide. So the key with this is understanding that this is actually just a division problem. Every fraction is just a division problem. A over b is just another way of writing a divided by b. And then we do the division, right? So a divided by b is the numerator divided by the denominator, and that's just math notation. People ask me, like, why is it always top divided by the bottom? Well, because that's what this actually mathematically means. It means to do a divided by b. You have to do that in the correct order. Now, with long division, we're used to the a value being larger than the b value. That can absolutely still happen, but it doesn't necessarily always happen. So let's come over here and see how this looks. Problem number 1 says 7/8. The first thing I want you to do is I want you to write for yourself what this really means. This is a over b, which really means a divided by b. This means 7 divided by 8, okay? What that means, now you also have to recall, let's put one more note to ourselves over here in green, okay? If I had, say, 125 over 5, and I wrote it like that, that would turn into 125 divided by 5. And remember, that would also turn into 125 divided by 5 when you set up your long division. Hopefully that all looks familiar to you. None of that is new. It's stuff you did in elementary, but we got to bring it back. So notice that the number on top is the number that also goes under the division bar. Now, we're used to stuff like this where, again, the A is larger than the B, but that is still going to be the case here, even when the A is not larger than the B. So this numerator, this first number, is the number that needs to go under the divide bar. So watch this. Here I go. I'm going to leave a space because I know that's where my answer goes. And I'm going to go 7 divided by 8. So I want to make sure you guys are clear here. These three things, this original fraction, this thing in pink, and this thing in green, it's 3 different ways to write the exact same thing. Okay? Now here's the thing though. Now you're supposed to go, if you remember your long division, you're supposed to go 8 into 7. You're supposed to do that division part right there. What do I do if 8 doesn't go into 7? I make this a decimal, 7.0. Okay? And as soon as I put that decimal there, I copy it up there. Again, all of this should be review, but if you're like, I don't remember any of this, it's okay, watch with me and write everything down and give it a few examples and it will come back to you. So how many times does 8 go into 7? Well, 0. I like to put that 0 placeholder in there when I'm dealing with a decimal. And then I go over to 70. How many times does 8 go into 70? Well, 8 times 9 is 72. That's a little too big. So 8 times 8. Remember, you put your factor up here, and then you multiply. 8 times 8 is 64. What do I do now? Oh yeah, I subtract the long division process. And I can borrow here if I need to. 10 minus 4, I'm subtracting right now, is 6. 6 minus 6 is 0. Well, what do I do now? Oh yeah, I add another 0. I can add as many zeros as I need to. And here's the reason I added a 0. I don't want any remainders. I'm going to keep going until one of two things happens, and you'll see. So I'm going to bring down the 0. One place value at a time with long division. One place value at a time. You subtract, bring down one more place value, keep going. 8 into 60 is 7 times, because 7 times 8 is 56. Subtract and get 4. I still have a remainder. That means I'm not done. I'm going to add one more place value. One place value at a time. 8 into 40 is 5. 5 times 8 is 40. Guess what? I just got a remainder of 0. Okay, everybody write this statement down, please. This is a really, really important piece that I want to make sure you understand. What we just discovered is that 7/8 is actually equal to, write this statement for me. 7/8 was the original fraction we started with. We did the long division and we got this decimal up here. That means 7/8 is actually equal to 0.875. They look very different, but they are in fact equivalent rational numbers. If I say I ate 7/8 of the candy bar, or if I say I ate 0.875 of the candy bar, I'm talking about the exact same amount of candy bar. They look different, but they come from the same mathematics, and therefore they are the same. Now, this decimal that we got, this fraction of 7/8, did that turn into a terminating or repeating decimal? The fact that I got to a remainder of 0 means that this decimal terminated or stopped. Terminating decimal means it stops. Okay, so what we just found out from that process is that 7/8 is equivalent to 0.875. Those are equivalent rational numbers, exact same amount. And we also learned that 7/8 turns into a terminating decimal. Let's try it again. Okay, so here's our process. Here's a new fraction. That means 9 divided by 20. If you ever doubt which order this should go in, say it out loud. Start with the top. 9 over 20 is 9 divided by 20. Okay, that means that this value on top this value that's first, I'm going to skip a space, and I'm going to put that underneath. And I'm going to tell you right now, I always just change it. I give it two zeros. I may or may not need those place values. I might need less, I might need more, but I just start with 9.00 under there because I know I'm going to have to add some. So I get my divide bar, and I am dividing this by 20. So this means 9 divided by 20. This pink one means 9 divided by 20, and this green one means 9 divided by 20. Don't forget to copy that decimal up, that's really important. 20 into 9, 0 times. So let's move over to the next place value. 20 into 90, 20, 40, 60, 80. 100 is too big, so that was 4 times. Now I multiply. 4 times 20 is 80. Now I subtract. 90 minus 80 is 10. Now this number that you get here, sometimes people get confused and they're like, they forget to bring down when they get a number that's more than the ones place. What matters right here with this number is that this number, the number you get when you subtract, should never be bigger than what you're dividing by. If it is, then you didn't go high enough on the last one. 10 is smaller than 20. I still need to bring down. You always bring down a place value, one place value at a time. You subtract, make sure that number you got is smaller than what you're dividing by, and then you bring down a place value. Okay, now we're doing 20 into 100. That's 20, 40, 60, 80, 100. That's 5 exact times. So here we go. I put a 5 up here. 5 times 20 is 100. And I already got a remainder of 0. Okay, what did we just learn? Here's what we just learned. Let's summarize it. We learned that 9/20 is equivalent to 0.45. That's the first thing we learned, is that this rational number in fraction form is equivalent to this rational number in decimal form. And in fact, if you recognize this one came up on our sleep survey task. And we looked at a different way to change it then. But the division will always work. Also, I got a remainder of 0, which means this decimal stopped, which means this is another example of a terminating decimal. 9/20 is equivalent to 0.45. That is a terminating decimal. Okay, one more together. Here we go. This means 5 divided by 9. So I'm going to write it that way. 5 divided by 9. This also means 5, I'm going to leave a space, and I'm going to put 0.00. I might need more, I might need less, I don't know. Divided by 9. I'm going to copy the decimal up. 9 into 5, 0. 9 into 50. 9 times 5 is 45. 9 times 6 is 54. So 6 is too big, so I'm going to stick with 5. 5 times 9, 45. Remember, now we subtract, and then we bring down the next place value. 9 into 50. Oh, we just did that. 5. 9 times 5 is 45. I'm going to subtract. Well, I still don't have 0 yet, so I could bring down another place value. 50. You see what's happening here? 9 into 40, okay. 5. What is going to happen here? Is this ever going to stop? If I keep adding zeros and bringing down, I'm going to keep getting 50, 50, 50, and 9 is going to keep going into that 5 times. We get 5, 45, 50, 5, 45, 50. Guess what this means? This means 5/9 is equivalent to, now I know that you saw these a little bit in elementary. We're going to work with them more this year. Let's make sure we know how to write it. This is just going to keep going, right? It's going to keep going. And that's one way that people write it sometimes, is with the dot, dot, dot. Let's take it to a secondary level and make sure we have our notation spot on. Here's another way we write this. 0.5. The 5 is the one that repeats, so we put a bar over the 5. 5/9 will always be equivalent to 0.5 repeating, and this is what it looks like when you get a repeating decimal. You'll get some kind of pattern like this that you'll keep subtracting, you'll keep bringing down, and you'll keep getting the same number over and over and over again in your long division, and that will mean you have a repeating decimal. Okay, at this point, I've done 3 of them for you. I want you to try that same process on 4, 5, and 6. show yourself in pink what the division problem is, set it up as a long division, find the equivalent decimal and tell me if it terminates or repeats, and then come back and see how you did. So everybody pause and try right now. Okay, check this out. I did the long division process on each of these. Notice 0 point and 0 point, and then this one was 1.41, which makes sense because this is the only example we've had so far that was improper, where the top number was bigger. So it does make sense that you'd have a value in the ones place. So let's go back and summarize these. This means that 17/25 is equivalent to 0.64. And because I got a 0, because I came to 0 as a remainder, that means that was a terminating decimal. This one I saw was starting to make this pattern. 80, 12 goes into 86 times, 72, 80, 12 goes 86 times. Now, the 1 and the 4 and the 1, those don't repeat. It didn't start repeating until the 6. So let's make sure we know how to write that. That means that 17/12 is equivalent to 1.41 with a bar only on the 6. It's still absolutely repeating, but only the 6 repeats, not the rest of it. So be careful of that. Make sure you only put a bar on what repeats. And 4/5, that one went quick. 4/5 terminated at 0.8. And here's the other great thing, you guys. If I've done the long division on something like 4/5 and I got 0.8, do you know what that means? That means 4/5 is always equivalent to 0.8. You don't have to do this long division over and over and over again if you get some of them in your brain. 4/5 will always be equivalent to 0.8, and 0.8 will always be equivalent to 4/5. And that's one of the things we're going to work on as we move forward, is getting faster at this and memorizing some of them so that we don't have to do this long division every time. Now, on your assignment, it's going to ask you to use a calculator to convert some of these. So, and it did say on this up at the top, it says, use your calculator to check it. Well, what would you type in your calculator? Well, you type in this pink part. And the calculator is very handy because it allows us to skip the long division part. But I wanted you to do the long division enough for your brain to process and understand what is the long division doing, okay? So when I type this pink part in my calculator, 7 divided by 8, that's what it looks like, but this is what it's doing. Your calculator's just doing that green part for you, okay? So when you go through and check all of these, you're always doing the top divided by the bottom. You're just letting your calculator do the long division for you, but your brain knows what the calculator's doing now. You're a better mathematician. You can use the calculator as long as you make your brain aware of what the calculator's doing. So when I type in 9 divided by 20, my calculator's doing this green part for me. And even something like this, when I type in 17 divided by 12, my calculator is doing this green part for me. And then some of you go, Ms. McGowan, there's a 7 in it. If we kept going, would we get a 7? No. Do you know what's happening? Your calculator is programmed to round. And so what would the next number be? It would be a 6. And of course, when the next number is 5 or higher, it rounds up. So this is just your calculator rounding. There is not a 7 there. Okay, now I'm going to show you really quickly a couple things I need you to know about how to type these in on your Canvas quiz. Okay, so real quick before we're done, we'll get to page 12 tomorrow, but before we're done with this today, I need you to know how to type things in. Okay, you are going to have to do a lot of typing in, as always, typing in your answers into Canvas, but it gets really tricky when you're trying to type in a repeating because you could type it in. Let me just show you an example. Okay, you're going to be able to use your calculator to practice this a lot. You know now that the process is all about long division and you know why that's working. So at this point, if you type it in your calculator, that's okay as long as your brain is processing and knows what is it that your calculator is doing for you. So for example, if you have a fraction such as 7/15, you know that that means 7 divided by 15. So if you type in your calculator 7 divided by 15, You're now just letting your calculator do the long division process for you, which is really why they were invented, not specifically for long division, but for some of those more tedious mathematical operations. We wanted to build a computer that did it for us and got rid of some of our human errors. So it's a helpful thing. So when I type this in, 7 divided by 15, the question then is, how do I type that answer? Because you're going to have some on your quiz practice today and for the rest of this week. How do I type this answer into Canvas? One more time, is there really a 7 at the end of this? No, your calculator is programmed to round. These 6s go on forever, okay? There's no 7 in there. So if I tried to put it so that the answer was, you know, if you type it in like this and then put the dots, but how many 6s do you type in? I don't know, that's tricky. So when you have to type in an answer to a repeating decimal, here's how you're going to do it. Are you ready? It's a tricky thing that we're using just for Canvas quiz. It's not a mathematical notation, it's just some handy trick that I'm using so that you guys know how to type in your answer and you know how to show me this is a repeating decimal. So you're gonna type on your keyboard 0 point, I always type the 0, 4, the 4 does not repeat, but the 6 does. If we were writing it on our paper, we just put a bar over it. Well, you don't have those kind of editing capabilities in Canvas. So here's what you're going to do instead. You're going to put brackets around just the repeating part. So I would type it in like this. Brackets, what are brackets? Look at your keyboard right now and look right next to the P button. See the P, the letter P? Right next to the letter P are some brackets. You don't need to hit shift and get those funny curly ones. You just need the normal brackets. So that's where you type those in your keyboard, and this is how you'll type it in. So let's just look at a couple more examples. If I gave you, say, 2 ninths, you could type in your calculator 2 divided by 9. And you would see, oh, this definitely repeats. And then people go, how come this one didn't put a 3 at the end? Because your calculator is programmed to round. And remember, rounding is if it is a 2, if the next number is going to be a 2, which it is, anything less than 5 keeps it the same. Those are the only 2 options. It either stays the same or it bumps up. Well, it would only bump up if this was 5, 6, 7, 8, or 9 next, and it's not. It's a 2 next. But if it fills up your whole calculator, it's a repeating decimal. So this, we typed in 2 divided by 9. This, if we were writing it on paper, we'd write it like that. Since we can't type it like that in Canvas, we would type it like this with brackets around the 2 because the 2 is what repeats. So now what if I gave you something like this? I don't know, 61 out of 100. And you're like, okay, that's 61 divided by 100, or maybe you know this one because I made it a hundredths place value. Either way, you type it in. Oh, that one does not repeat. How do I type it into Canvas? Well, you type it in exactly how it looks. You don't need anything special if it's a terminating decimal. So when you're done with this video, you're going to type in the answer to the question, take a picture of your notes, and then of course you're going to do your math practice. You're going to have to type in some repeating decimals, and I'll even show you what it says at the top of, pause please, awkward pause while I find the right screen. Here we are. So you can even see on the top of this quiz here, in the quiz instructions, it shows you a reminder right here. Remember, type only the repeating parts of the decimal in brackets like this. So if you saw this in your calculator, guess what? Your calculator would put a 6 at the end because it's programmed to round. There's no 6 at the end. But you would type it in like this. The 2.1 does not repeat, only the 5 repeats. So put the repeating parts in the brackets. Let me know if you have any questions. You guys can do it.